Hi, I am 3 honors students. Long time no see. We're going to start chapter 9 today. And chapter 9 is about polynomial functions. And so our first day in polynomial functions will be section 911, and we will be solving by factoring. So I'm going to go over the steps of factoring, some of which you did last year in IM2, but we're going to go ahead and review those and add a little bit more. So the first step to factoring, right? If you're factoring, the first thing that you always want to do is you always want to look for a GCF. If I could spell, a GCF, a greatest common factor. So see if they have a factor in common and factor it out first. That's always what you do first in factoring. The second thing that is good to do is to look for a special case. And a special case is going to have a perfect square, is going to have perfect squares in it or perfect cubes in it. So you need to know your squares and your cubes. All right, so the first special case that we dealt with in IM2 was a difference of squares, or a difference of perfect squares. And in a difference of squares, you had something like a squared minus b squared. So the difference is the subtraction sign in it. And that factored to be a plus b times a minus b. Probably one of your favorites because pretty simple to see. Okay, after difference of squares, we talked about a perfect square trinomial. And a perfect square trinomial looks like this: a squared plus 2ab plus b squared. And when we go to factor that, that is actually a plus b squared. Okay, now this can have an addition sign here, a plus 2ab, or it could have a minus 2ab or a subtraction or be a difference. If that happens, then the only thing that's different is that is a minus there in the second one. So it's a minus b quantity squared. And those are perfect squares. So when you see perfect squares. The next special case involves perfect cubes. So it can be a difference or a sum of perfect cubes. Okay. And so we'll start with difference. A cubed minus b cubed will factor to be a minus b times the quantity a squared plus ab plus b squared. Okay, and you can't see that, so let me move it up. There you go. So a minus b times the quantity a squared plus ab plus b squared. That's if it's a difference. If it's a sum, then these two signs right here change. The last one is always positive, but this will change to a plus and a minus. And I'll give you a trick as we go through on that one to remember the pattern. So those are your special cases. These first two involve perfect squares, and the third one is perfect cubes. Okay. The third method that we learned was star. Okay. And here we had ax, and we had a times c, and we had b here. And we use this when we have a trinomial. It's often when we would look to use the star or 3 terms. That doesn't mean it works for all trinomials. It just means that's when we would look to use it. Okay. And our fourth method is new. Our fourth method is to factor by grouping. And I will show you how to group. Essentially, you group 2 terms together and 2 terms together. And so you have to have 4 terms in order to do factor by grouping. You have to have 4 terms. And we essentially find the GCF in these two and the GCF in those two. So we'll go over a couple of those today as well. So those are our methods for factoring. So GCF, special cases, star, and grouping. And we're going to practice those. So we're going to go through and do a bunch of example problems today and practice. All right. Okay, so let's look at our first example. Our first example says factor completely and solve. Factor completely and solve. So we're going to factor this. So we're going to use our steps. GCF, is there a common factor in those three terms? No. Is x squared a perfect square? Yes. Is 12 a perfect square? No. So it can't be a perfect square trinomial. Cube, is x squared a perfect cube? No. So that brings us to star. How many terms are here? 3 terms, so let's use star. Okay. If you forgot how to use star, we'll review it. If you can factor without using star, you don't have to use star. But if there's a leading coefficient, I expect to see the star, other than 1 anyways. Okay, so here we go. We grab this and we put an x here and an x here. We multiply a times c, since a is 1. 1 times 12 is 12. Our middle term is b, which is negative 8. And so we need to ask ourselves, what are two numbers that multiply to be 12 and add to be negative 8? If you have trouble factoring, list out all the things that you need it to multiply to be, all the factors of your top number here, 12. So 1 times 12, 2 times 6, 3 times 4. So those all multiply to be 12. None of those add up to be negative 8. So in order for two things to multiply to be a positive and add to be a negative, they would both need to be negative. And so now these two here in the middle add to be negative 8. They're negative 2 and negative 6. So we're going to write this as x minus 2 in parentheses times x minus 6 in parentheses equals 0. And I expect to see that factored step, or you're not showing your work and you won't get full credit. You set the factors equal to 0, x minus 2 equals 0, x minus 6 equals 0, and so your answers are x equals 2 and 6. And so you factored it here. This is factored. And this one down here, this one is solved. So you needed to factor it and solve it. So we did both of those. All right. You should remember how to do that from IM2. Let's take a look at our next example. Our next example says that we are going to factor completely and solve, and we have 2x cubed minus 7x squared plus 6x equals 0. And so we need to factor this. So our first step in factoring is always to look for a GCF. So you're going to look in those pieces and see, is there something that they all have in common? Is there a common factor that can be divided out or factored out? Well, 2 goes into 2, but it doesn't go into 7. But notice that they all have an x. So we are going to factor out an x. And that is going to leave us with a 2x squared minus, here we'll have a 7x. And here, when we factor out our x or divide out our x, we'll have a plus 6 equals 0. So we factored out our x. We used our GCF. Now, it does say factor completely, so we need to see, can this be factored some more? 2 is not a perfect square or a perfect cube, so it's not going to be a special case. But it does have 3 terms, so let's try and use star. So over here, I'm going to do my star. I'm going to take my 2x and my 2x, because my leading coefficient is 2 this time. 2 times 6 is 12, and they need to add up to negative 7. Well, I already listed out all the factors of 12 in the last problem, 1 and 12, 2 and 6, 3 and 4. And we talked about the fact that they would both have to be negative to make a sum. that is negative. So how about a -3 and a -4? So we're going to grab this term here and we're going to write it down. Oh, don't forget your GCF is out in front, so you have x. And this first term is 2x minus 3. Now, this other term over here, this 2x minus 4, you need to always remember to reduce if you can. So 2 goes into 2 once, 2 goes into 4 twice. So it is going to be x minus 2. This is now factored completely. We cannot factor it anymore, so we factored completely. And lastly, we want to solve. So how are we going to solve? We are going to set each of our factors equal to 0. So I'm going to get x equals 0. If you have trouble with this one, it's going to be a fraction. 2x minus 3 equals 0. 2x equals 3. So x equals 3 halves. And then this one over here is going to give you an x equals 2. So this time you have 3 answers. The reason you have 3 answers or 3 solutions is because this is an x cubed. 0, 3 halves, and 2. All right. We are now on example number 3. So here's our example number 3. Hopefully I don't run out of room. All right, so first off, I notice this one looks a little bit different because it is not equal to 0. I also noticed that my leading coefficient has a negative, and having a leading coefficient that is a negative is kind of a problem in factoring. So you always want your leading coefficient to be positive. So instead of moving the 49 to the left, I'm going to move all my terms to the right. And so this time I'm going to have 0 equals. When I move that 4x squared over, it's going to become a positive. When I move the 28x over, it's going to be a negative, and the 49 is on the right already, so it's going to stay 49. So now I'm going to look, do they have a GCF? Do they all have something in common? 4 goes into 4, 4 goes into 28, but it doesn't go into 49. 2 goes into 4 and 28, but not 49. So then I go on to special cases. Is 4 a perfect square? Yes. So is x squared. Good. Is 49 a perfect square? Yes. So this is a perfect square trinomial. So I am going to write this as 2, so I essentially take the square root of this, or say what times itself makes 4x squared. So 2x times 2x will be 4x squared. And the square root of 49, or 7 times 7, is 49. And then to make a middle term that's negative 28, I need a minus in here, because that'll give me a negative 14 and another negative 14, because there are 2 factors. So I have factored this completely. And now I just need to solve. And so I'm going to say take 2x minus 7 and set it equal to 0. 2x equals 7. So x equals 7 halves. Even though this is a quadratic, it only has one answer because that answer happens twice because of the squared. So it's called a double root. We'll learn more about that later on. Okay. All right, we're going to move on to example 4. Yes, we have a lot of examples. Been a while. Ooh, I like this one. Number 4. This is a new one for you guys. So, GCF, is there any number that goes into 8 that goes into 27? No. Is 8 a perfect square? No. Is 8 a perfect cube? 2 times 2 times 2 is 8. So 8 is a perfect cube. What about 27? Is 27 a perfect cube? 3 times 3 times 3 is 27. So 27 is a perfect cube. So this is a difference of perfect cubes. So for the pattern, what we do is we say, what is being cubed to make this? Or what is the cube root of this? So 2 times 2 times 2 makes 8. And x times x times x makes x cubed. So we're going to use the 2x that creates this. And then 3 times 3 times 3 makes 27. Or the cube root of 27 is 3. So I am going to put my 2x and my 3 in there. Now, the pattern here is that you are going to, I'll say, square your first, square your last, and multiply the 2. Oops. Square your first, square your last, and multiply the 2. So square your first. So square this guy here. 2 squared is 4, x squared, right? 2x squared is 4x squared. 3 squared is 9. For this middle term, we multiply these two, and we get 6x. Now you just need the signs, and I'm going to use the word soap to remember that, soap. So this sign in here is the same. This sign is the opposite, and this is always positive. So this guy is always positive. This is the same as what we started with, and this is the opposite of what we started with. So it is factored completely. 2x minus 3, that quantity, times the quantity 4x squared plus 6x plus 9 equals 0. So we have factored this. Now, we have not factored it completely because right here, this guy is not factorable. So if we need to solve him, we actually have to use the quadratic formula, which we'll review in a couple days. But this guy would lead to 2 more answers with the quadratic formula. They could be irrational, they could be imaginary, all sorts. I'll leave that for in a couple days. We'll just go ahead and solve this guy. So 2x minus 3 equals 0. So x is going to be 3 halves. And it's also going to have 2 answers here from this guy using the quadratic formula, but we'll do that later this week. Okay? So we would have another answer here and another answer there. All right, let's take a look at our next example. Example 5. Do they all have an x? No. So no GCF. Is x cubed a perfect cube? Yes. Is it a perfect square? No. Is 12 a perfect cube? No. All right. Does it have 3 terms? No. So we're not going to use star. So it's got 1, 2, 3, 4 terms. We're going to use this new factor by grouping. And when we factor by grouping, we are going to grab these first 2 terms and we're going to pull out their GCF. So what do those 2 terms have in common that we can factor out? We can factor out an x squared. If we factor out an x squared, that'll leave us with an x. If we factor out an x squared, that'll leave us with a plus 3. We're going to group the next 2 terms together. And what do those 2 terms have in common? Well, the leading coefficient has a negative. The leading coefficient has a negative, so we're going to factor out that negative. And what goes into 4 and 12 is, I thought I was going to sneeze, but it went away. Okay, 4. So we're going to factor out a 4 out of both of those. That's going to leave us with, when we factor out a 4, it's going to leave us with an x. When we factor a negative 4 out, right, because that negative, this is going to leave us with a positive 3. And to check that, negative 4 times positive 3 is a negative 12. So this is what we have at the moment. These 2 terms here need to be the same. Or you can't factor by grouping, or you did something wrong. Are those 2 term expressions, pieces, factors, are those the same? And the answer is yes. So we're going to factor it out. When you factor it out, it divides out of both of those pieces. And then we're going to write what's left over in our second set of parentheses, x squared minus 4. We're going to look at this. This is a factor and can't be factored anymore. Can this be factored anymore? Is there anything you notice about it? You might notice that x squared is a perfect square and 4 is a perfect square. So you're going to get an x plus 2 and an x minus 2. And you have 3 factors. It is a cube. And so you also have 3 solutions, -3 and plus or minus 2, a positive or a -2. You can write them separate as well. Okay, so it was a factor by grouping. Leave it there for a second. You can also pause the video or replay the video if you have to see that again. We're going to go on to example 6. Here's example 6. GCF, special, star, grouping. It's kind of the list you go through every time. So hopefully you decided that this is a factor by grouping. Find the GCF of those two. What's left over? 2x minus 5. Find the GCF of these two. 9. 9 goes into both of those. Are those the same? Then we can factor them out. 2x minus 5. X squared plus 9. Is this a difference of perfect squares? It's not a difference because it has a plus, so it can't factor over the set of real numbers. But I'm going to show you something after we solve it. So I'm going to set both of these factors equal to 0. Here I'm going to get x equals 5/2. And here I'm going to get x squared equals -9 square root both sides, x equals plus or minus. The square root of 9 is 3, and the square root of a negative is I. So when I solve it, I have 3 answers: 5/2, positive 3i, and negative 3i. So if I want this factored completely over the set of complex numbers, then I would need this factor 2x minus 5. And I would also need these as factors. So I would need an x minus 3i and an x plus 3i. And this is actually factored completely. You write that, factored completely over the complex numbers, capital C, curly like that, or complex numbers. Okay. So it has one real rational solution, and it has 2 complex solutions. They're actually called complex conjugates. All right, moving on. Number 7. Number 7, take a look at it. Perfect square, not a perfect square. Somebody liked 12 today. 12 pops up a lot today. All right, it is not a perfect square. Sorry about that. It is not a perfect cube. It does not have a GCF. It does not have 4 terms. So the only thing that leaves is star. Normally, when this is an x squared, we put our x here and here. Since it's an x to the 4th, it's actually an x squared and an x squared that go there in our star. The 2 numbers that multiply to be -12 and add to be a +1. Those 2 numbers are 4 and -3. +4 and a -3. So one of my factors is x squared plus 4, and my other factor is x squared minus 3. So those are my um, factors over the real number system or the rational number system. But now I need to solve those to find out my answers or my solutions. So x squared plus 4 equals 0, and x squared minus 3 equals 0. X squared is going to equal negative 4. So x is going to equal plus or minus 2i. Over here, x squared is going to equal 3. So x is going to equal plus or minus the square root of 3. So here I have two irrational zeros, and here I have two complex zeros. If I want to factor this over the set of complex numbers, I need all four factors. And so I'm going to have an x minus 2i, an x plus 2i, an x minus root 3, and an x plus root 3. So I have to have all four of those factors if it's factored completely over the complex numbers. All right, so these are solutions, these are factors. They're related to each other, but they are not the same. Okay, so that is your examples for today and your notes for today. You should have all picked up a packet. If you didn't pick up a packet, I think they're still available at Monte Vista. Just let your teacher know. And you'll see here that today is 911 solved by factoring, and there's a worksheet. So this worksheet is what you are going to be doing. And you're going to continue until your worksheet stops. And how do you know your worksheet stops? It's because the next one starts. So this actually has 26 problems on it. So it's quite long. It's 2 full pages or 4 sides. And then that'll be tomorrow's worksheet. And this week we have all worksheets for homework, and you're going to post your worksheets in Schoology just like you would if you did bookwork. Next week we have a quiz and bookwork, so just be aware of that when that comes up. Tuesday, Wednesday, Thursday, Friday this week are all live Zooms. I expect you to be there. They're mandatory. They're part of the class. So I'll see you tomorrow.